prime factorization. And the key word here is the word prime. Prime numbers are numbers that only have two factors. So a list of prime numbers would be something like 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. These four numbers right here, those are like your main four prime numbers. Like these are the four that we're going to be using most often. There are more prime numbers, of course, numbers like 11 and 13 and 17 and 19. These four prime numbers in red are kind of like your secondary prime numbers. These are the ones that we're going to see occasionally doing prime factorization, but we're certainly not going to see them as often as we see these prime numbers in blue. So make sure that you're taking the time to remember, at least the small prime numbers. And these 8 are probably the most important ones, okay? In order to create a multiplication problem, and that's what the word product means, we are going to create a multiplication problem containing prime numbers. In order to do that, we're going to create a factor tree. You'll see what a factor tree looks like in just a second. We're going to create a factor tree, and that factor tree is going to help us get our answer. But this is really important. We have to remember that the factor tree itself is not the answer. It's simply a tool that we're going to use to create the answer, okay? So the factor tree is not the answer. The factor tree is a tool, not the answer. Okay, let's move on. So let me start by basically modeling prime factorization. I'm going to take a number, and in this case, I'm going to take the number 240, and I'm going to break it down into its prime factors. At the end of the math problem, I will have a multiplication problem. If we do the multiplication, we're going to get the number 240. We're not going to actually do the multiplication, but just know that we're going to create a multiplication problem that equals 240, the number that we start with. When we create factor trees, we really have two options. We can slice up this number using a small tool like a butter knife. And a butter knife is just like, you've seen a butter knife before. It's technically a knife, but it's not sharp at all. It's primarily used for cutting thin layers of butter, so you could put it on your toast or something like that. And so we could slice up 240 in a lot of really, really small pieces. Like we're going to use really small numbers like 2 and 3 all the time. Or we could chop it up with a chainsaw. Now both of these tools are used for cutting, but one does it a lot faster. But just like real life, using a butter knife is probably easier in many respects than using a chainsaw. Chainsaws, they're a faster tool to use, but they could be dangerous. All right, if you're not familiar with how to use a chainsaw, it could actually come back and haunt you. All right, so let's take a look at both examples. Let's go ahead and start with the butter knife example. Now I'm going to start by writing the number that I'm about to slice up. And my goal here is to create two numbers that multiply together to turn into 240. But remember, not just any two numbers. Our goal is to find prime numbers, 2, 3, 5, 7, and then I'll change up the color, 11, 13, 17, 19. We want to cut up 240 using these numbers. Well, a butter knife, let's start with the smallest number. 2 does go into 240 120 times. And if you look, these two numbers together would multiply to create the number above it. 2 times 120 is 240. We don't actually have to draw this multiplication sign. I just wanted to tell you that's what's going on. Since 2 is a prime number, I'm going to circle it, right? Because I'm trying to find prime numbers. I found one, I circle it. I'm done with it. I'm not going to touch that 2. 120 is not a prime number, so I have to keep slicing it. And since I'm using the butter knife method, I'm going to stick with the number 2. 2 times 60 is 120. Again, 2 is prime, so I'll circle it. 2 times 30 is 120. Again, 2 is prime, so 2 times 30 is 60, not 120. 2 times 15 is the number 30. Oh no, I can't use the number 2 anymore. That's okay. In the butter knife method, we just kind of move down and we go, okay, well, can we use the number 3? And the answer is yes. 3 times 5 is going to be 15. And what we've done is we've taken the number 240 and we've chopped it down into all of these prime numbers. You see these numbers that I've circled? These are prime numbers. The answer to this math problem is going to be taking all of these prime numbers and multiplying them together. 2 times another 2. 2 times another 2. 2 times another 2. 2 times 3 times 5. Technically, this is our answer. These numbers, when multiplied together, will create 240. What we've done is we've broken it down into its prime factors. Now, there is a better way of writing this, so this is technically not correct yet. There is a better way of writing this. We want to make sure that we're writing this appropriately. And quite frankly, we can write this better. All of these 2's, we can write in a shorter version. Instead of writing 2 times 2 times 2 times 2, we can write that as 2 to the 4th times 3 times 5. This is the correct way of showing our answer. So correct This is the correct way of showing our answer. We want to write our prime factorization answers using powers when possible. All right, let's take a look at the exact same math problem, but this time let's use a chainsaw method. Now, the goal with the chainsaw method is we're still going to focus on these prime numbers, right? Like our goal is still to create all of these prime numbers that we were trying to create before. But instead of focusing on them right away, our goal is going to be to take this relatively large number, 240, and chop it into a much smaller number as quickly as possible. Now, I could do 2 and 120, but 120 is still a big number. What if we go like this? What if we say 10 and 24? Isn't 10 times 24 240? Yeah, it is. But what we've done is we have not created a prime number, so I cannot circle either one of these, but we've made the two numbers that we're looking at much smaller, much quicker. And so since neither one of these are circled, we have to continue breaking them down. 10 can break down to 2 times 5. Both of these are prime numbers. 24 we could break down a bunch of different ways. We could say 2 and 12. We could say 8 and 3. We could say 4 and 6. Let's just go ahead. Let's go with 4 times 6. 4 times 6 is 24. 4 is not prime, 6 not prime. But we can make them prime. 2 times 2 is 4. 2 times 3 is 6. And you'll notice that the chainsaw method, the factor tree is a little bit smaller because we're chopping the numbers faster. That is a benefit. The downside of this chainsaw method is you have to be a little bit more careful because the numbers are not in order. If we go back a slide, look at these numbers. They're in order. 2, 2, 2, 2, 3, 5. Over here we have like 2, 5, 2, 2, 2, 3. They're not in order, so we have to pay a little bit more attention. We have 1, 2, 3, 4 2s. 2 to the 4th. We have 1, 3. We have 1, 5. Does this answer look familiar? It should, because it's the exact same answer that we got by using the butter knife method. So I guess the thing that we need to learn here is that it doesn't matter how we chop up this number. If we do our math correctly, we will always end up with the exact same answer. Now, some people ask which method is better, the butter knife or the chainsaw. It's really kind of up to you. It's up to what you're comfortable with. The correct answer is probably using both. You know, sometimes cutting the numbers really big, sometimes being a little bit more delicate and using a bunch of 2s. Let's take a look at this one real quick. 84. Let's use a little bit of both, right? So let's start by going like this. 2 and 42. 2 times 42 is 84. Let's say at this point you look at 42 and you go, well, actually, you know what? 6 times 7 is 42. 7 is prime, by the way. And so you'll notice here that I've kind of used a hybrid. I started off kind of butter knifing it, but then I recognized a place where I could use a chainsaw. And then here we go, we have our answer. We got 2 squared times 3 times 7. And again, this is our answer. And now you might be wondering, like, Mr. Waller, why are we doing this in general? You know, why are we breaking these numbers down? When are we ever going to use this? Well, let me kind of help, right? Let's take this number, 84, and let's take the previous number, which was 240, and let's write it as a fraction. 84 over 240. The reason that we do prime factorization is that we want to be able to reduce fractions accurately. And let's say you did a big old math problem, and this is your answer. You know it's the right answer, but you have to reduce it. You've never been really confident at reducing, and so we're going to utilize this method. Now, let me kind of erase a little bit of my work here. 84 can be written like this. What I'm going to do is I'm actually going to kind of write it the long way out. All right, so just bear with me. This number right here is 84. 240, if we go back a couple slides, 240 can be written like this. Okay, so it was 2 to the 4th times 3 times 5, I think, 5. 240 can be written like this. And so all that we've done is we've written 84 slightly differently, we've written 240 slightly differently, but one of the really neat parts about fractions is that if you have a number in the numerator and in the denominator, they can cancel each other out. So like this 2 and this 2 can cancel, this 2 and this 2 can cancel, this 3 and this 3 can cancel. Can anything else cancel? No. And so what we're left with is in the numerator we have a 7, and in the denominator we have 2 times 2, which is 4, 4 times 5, which is 20. This fraction can reduce to 7 over 20. And that's kind of why we do this. Now in the future, we're going to have, I may as well show you now, right? Let's erase most of this, I think. Let's get rid of this. In the future, we're going to have numbers that kind of look like this. Okay, so don't get like worried about this, but you know, we're gonna have numbers that kind of look like this. And we have to reduce it. And you might be thinking, well, how can I reduce these letters? We've learned today that, you know, m to the 3rd power can be written like this. It's m, 3m's, m times m times m. Y to the 2nd power could be written like this, y times y. So this top green number is written right here in red, just kind of spaced out. This bottom number I can write in blue. M squared is m times n. Y to the fourth is y times y times y times y. And then the same thing that we did before, we could do again. This m can cancel that m. This m can cancel that m. This y can cancel that y. This y can cancel that y. And if I actually use my eraser this time, and I actually erase all of the numbers or letters that we've canceled away, you can see the fully reduced answer. It's 5 times m, 5m, over 7 times y, 7y squared. And that is this fraction fully reduced. All that we're doing is we're kind of breaking it down into its factors and then canceling what we can cancel. All right, let's kind of really quickly, let's go through 2 more examples and I'll be done. Let's go 8 and 100. The 8's not prime, so we kind of have to chop it up. Do remember to circle your prime numbers. They'll be easier to find. Again, 10 is not prime. 10 is not prime. So the answer to this problem, we have to be careful. 1, 2, 3, 4, 5. We have 5 2's all multiplying together, and we have 2 5's. This number right here, if we were to actually multiply it, will give us that 800. Okay. Last one. Now you'll notice this m squared. I'm going to periodically kind of throw variables into our math problems, mostly so that when we see them, we don't get scared in the future. Okay. Let's talk about this m squared at the very end. Right now, let's focus on the number 1,100. I could break it down like a butter knife and have like 2 and 550, but I don't really want to because 550 is too big of a number. So let's think of a bigger number. How about 11 times 100, right? 11 times 100 is this number. 11 is prime, 100 obviously is not. 10 times 10. Neither one of these are prime, so we're gonna have to break them up. 2 and a 5, that makes 10. 2 and a 5, that makes the other 10. So the answer to this problem is 2 times 2, 2 squared, times 5 times 5, 5 squared, times 11. And then let's not forget about the m squared. The m squared is just going to kind of fall down and become part of our answer. If we were to multiply this, these numbers would turn into 1,100, and the m squared would just stay in m squared. And that's how we do that with variables at the end. I know it doesn't really change very much, but I just want you to be able to see them and know that they don't really affect the problem right now, but they do exist, so we want them to be a part of it.
Okay, there you have it. Prime factorization is a very important skill for the future. And not only does it help us reduce fractions, but it's going to be absolutely essential for other skills like greatest common factor and least common multiple. Thank you for watching Mr. Waller Teach Me Math.